Alright guys, let's come back. Let's bring it back. Let's bring it back. So quick story. So I did this break, 1 minute break thing last year, and there was someone observing me when I did it. So then when I met with them afterwards, they're like, how'd you do this like break thing? You said wait for the minute, right? You guys should have been working. And there's another teacher, right? So I asked the teacher, I said, how many times when we have our meetings on Wednesdays have you stepped out in the middle to like check your cell phone, check your email, or get some food? And they were like, I do it all the time. And I was like, I think about the way a student feels when they can't leave it all in the middle of a class. They can't check their phone at all. Like, oh damn, I never thought of it that way. And then I was like, imagine it even more. They do this every day for not just one class, not just one meeting, basically 8 or 9 meetings a day. And like that made her like, oh wow. And I feel like as like teachers, we often don't think about how you all feel like during a day. So I definitely want to try to have these 1 minute breaks. Now I did not come up with this idea. So I was reading an article about a guy, so a teacher, who shadowed one of his students for a whole day. Like went with the kid to every single class, like did all the work that the kid did, like had the lunch food that the kid had, everything. Exactly like shadowed the kid. And at the end of the day, he said, I was so tired from just like sitting 8 hours listening. I couldn't check my phone at all. He was like, I felt so like disconnected and everything. And then he's like, now I understand what a real student is. I think I should do that, yeah. Maybe I'll take a day off and shadow what it was.
And homework also.
And the homework. I do the homework. I make the answer key.
All classes?
All classes, yeah. Okay, here we go. All right. So, having told that story, let's jump right in. Okay, so we're on number 11. So I will definitely, so I cannot commit to giving you all breaks in the middle. So this is the problem we have in front of us. Yes, ma'am.
Oh. I think we have to review gender.
Yeah. All right, here we go. So, again, yesterday we did a model problem where we said, you know, you can solve this out using the quadratic formula, but I think it's easier to rewrite sine, right, as u, right? So let u equal sine of, and don't put x this time because this time we have a 2x here. We'll deal with that later on. That'll be the new piece. But just let u equal sine 2x. Right? Let u equal sine 2x. So now, when we rewrite our equation, we have this. And now this equation everybody can factor. So what we want to do for the next 2 minutes, factor this, set it equal to 0, solve for u. Let's take 2 minutes to do that. Factor, solve, set it equal to 0, solve for u. Don't worry about plugging in. We'll do that together at the end. In other words, don't worry about replacing u with this. Just worry about factoring, setting equal to 0, and solve. Take 2 minutes off. There are many ways to factor. Some of you are using the X box. Others of you might be able to do the factoring in your head. Great. Regardless, and don't look up until you want to see what you should get, we hope you get this. We hope you get this when you factor. Again, if you're unsure about how to get this, let me know. But step 1 is let's just get this when we factor. Now we want to set equal to 0. We've already got 0 here. So I'm just going to write, this is my indication to you all. And you all might want to write this on your paper. This is set each piece equal to 0. Let's go ahead and do that. Each piece equal to 0. Remember, this is zero product property. So each piece is being set equal to 0. And then I can solve for u, isolate the variable. So we set each piece equal to 0. And now these two equations can be solved for u. So isolate u. Do you know that, Dan? Whoever said that. Whoever said that. So we are isolating, folks. So we hope everybody gets down to these two solutions for you. Are there questions on how to solve this? Please let me know. If you've gotten this, now replace the u with what it actually was. If you've gotten to here, replace u with what it actually was. Because remember, we made the substitution. So replace u with what it originally used to be. So we're replacing u with what it originally was. So we are here, and we're going to replace the u with what it was. If you flip back, you see that we had this. Again, are there any questions on getting up to here? Okay, yesterday when we solved problems, this was just 1x. Like there was no multiplier here. So this is the new piece. If there is a multiplier, all we need to do is do another u substitution. Don't call it u because you already used it, so the custom is to just use v. So we'll just say let v equal 2x. So if this had been 3x here, we would have had let v equal 3x. If this had been 20x, it would be let v equal 20x. And again, we'll show you why that's important. But now, for right now, just replace the 2x with v. So our new equation looks like the following. And now here, everybody knows how to solve for v. Think about the unit circle, solve for v. Take a minute, think about the unit circle, and get both answers, in other words, both equations, solve both equations for v. This is straight unit circle. We'll get there. We will. And again, verify by looking up here whenever you're ready, no rush. Any questions on solving for v? And now, we need to finish by getting rid of these v's. Remember, v was just 2x, and the whole goal at the beginning was to solve for x. So replace these v's with 2x. Because remember, v is just another way of writing 2x. It just made our life a little bit easier. So replace v with 2x. So I have, in other words, 2x equals 7 pi over 6. 2x equals 11 pi over 6. And 2x equals pi over 2. And now, final step, solve for x. Solve for x. You might need to do some keep, change, flip, some of you. Some of you might be able to do it in your head, regardless. Please verify whenever you're ready. Again, please don't look up until you're ready. No one's rushing you. Let's make sure we're comfortable getting this. So here we are. Are there any questions on getting this? Please ask me. Leslie? The ones in gray? Okay, so all I did is I divided each of these sides by 2. You good with that? Because I wanted to get x by itself. So 2x divided by 2 is x, 2x divided by 2 is x, 2x divided by 2 is x. So they all just have x over here. Pi over 2 divided by 2, you can do the math on separate sheet. Pi over 2 divided by 2 is the same as keep, change, flip. Okay. Okay, now here's the interesting thing. If we think back to our number line here, this problem asks us to go from 0 to 2 pi. So here's our number line. 0 to 2 pi. Let's put pi here to be helpful. And here's what I want to show you all. The answers we got right here, the 7 pi over 6, the 11 pi over 6, and the pi over 2. In other words, those three answers go all the way from 0 to 2 pi. Yeah. So the answers we got before, 7 pi over 6, 11 pi over 6, pi over 2, before we divided, went from 0 to 2 pi. These answers, however, only go from 0 to pi. In other words, these answers, bless you, are only between 0 and pi. If you look at all of these values, all of them are smaller than pi and bigger than 0. And the reason for that is the following. If you look at our equation, it was sine of 2x. What is the period of this? Well, if you think back to your midline amplitude period, we always said that period is 2 pi over b. In this case, b is 2. So the period is 2 pi over 2, which is pi. So what have we shown here? We've shown basically that this equation will repeat every time we go pi. The cycle or the period is pi. So between 0 and 2 pi, there are 2 cycles, not just one. Regular sine of x has only one cycle from 0 to 2 pi. It has 2 cycles from 0 to 4 pi, which is why we add to get more solution. Every time there's another cycle, there must be more solutions. So here, this part from pi to 2 pi, pi to 2 pi is another cycle, which means there must be more solutions here. There must be more solutions here. So we need to find these solutions now. We got these. We got to find these 3. So the question is, how do we go from here to here? Add pi. Not 2 pi, because the period now is just pi. Period is no longer 2 pi.
And we're going to add the pi to the results we got?
To the gray results, that's right. Because the gray results are the one in this zone. And we need to add pi to get the results in this zone. The number line makes life a lot easier if you think in terms of the number line. So let's go ahead and do that. To all of these 3, you need to add pi. And if you want to be specific, I remember David Torres in the other class said, really we're adding pi over 1. That's going to help you when you do the common denominator. So you're really adding pi over 1.